Hello, everyone. My name is Florina, and I'm a developer advocate at Google. And in the last few months, together with 3 of my colleagues, we've been trying to bring Plaid back in fashion. Plaid is actually Nick Butcher's application, and he started developing somewhere around 2014 as a way of showcasing material design. So Plaid aggregates data from 3 different sources: designer news, Dribble, and Product Hunt. And what Nick did here is use all sorts of Android APIs, like shared element transitions and all sorts of fancy animations that really show how the user experience can be improved by applying material design principles. He also added all sorts of very fancy animated vector drawables. So I remember when I used Plaid for the first time, I think I pressed that search button 100 times just to see that magnifier transform into an arrow. It was pretty cool. So the video that you saw earlier was actually from 2016, when it was Plaid's glory time. Because from 2016 until 2018, things changed a little bit. And that's because some of the APIs were deprecated. So for example, with Dribble, now if you're scrolling, you see just a progress bar that's loading without being able to actually see the comments for that shot. Also, pressing on likes just gives us the number of fans, and that's it. So that's because part of the API was deprecated. We can no longer actually like a shot. We can no longer follow a user. So this means that step by step, almost half, if not more, of this functionality was gone. Well, with designer news, things were actually even worse. So for example, in designer news, for a story, you can see the comments. And the comments are threaded. And you cannot add a reply either to the story, a comment to either the story, or as a reply to another comment. So in order to easily differentiate to which comment you're actually adding a reply, Nick added this nice effect of elevating the comment that you've just touched. And I think my favorite feature in the entire Plaid app, and the feature that still makes me gasp when I see it, is this reflow text. So Nick worked a lot on arranging exactly the speed of the text, the way the words move. If you actually look at it, you see that they move in an arc. It's not a straight line. He did an amazing job there. And he also did a talk about it in DroidCon New York 2016. So if you want to see how everything was implemented, check that talk out. But the problem with designer news is that the entire API was deprecated. So the entire V1 was no longer there. So this means that in Plaid, we could no longer see the comments or this awesome reflow text. What was working, though, was Product Hunt. Just that with Product Hunt, well, you were tapping on an item, and we were just opening a Chrome custom tab, and that was it. So nothing very fancy here. So this meant that from 2016 until now, we ended up with decreasing step by step the feature of Plaid. So from that initial beautiful shirt, we ended up with, well, something quite plain. So we decided that we shouldn't leave it like this. Plaid is such an awesome application. So together with 3 of my colleagues, with Nick Butcher, Ben Weiss, and Tim Song, we decided we wanted to bring Plaid back to life. So more precisely, we wanted to make sure that we're fixing the broken functionality. But also, if you look at the code, you see that it's using quite outdated technology. In the end, it was started in 2014, so it wasn't using any of these fancy MV star patterns. So we wanted to build something that's modular, that's extensible, and of course, based on the guide to app architecture that we're recommending, and Kotlin. So you know how it is, measure twice, cut once. So before we wanted to cut, we decided to define how we want to restitch Plaid back. So we knew that, OK, we have 3 different sources. So each of these sources should be in their own module. So like this, we can easily plug and play another data source when we want to extend the app. Even more, what we found it would be interesting is we have a filter list here. So whenever we want to add another source to that filter list and then actually see the items there, only at that time when the user clicks on the item to download the code for that. So this is possible with the new app model that we released this year at I/O, the app bundles, and more precisely with dynamic feature modules, which are part of the app bundles. So with the dynamic feature modules, you can, in a module, you would put all your code and all your resources, and if you enable the dynamic downloading, then it means that they will only be downloaded at runtime. So we wanted to have this clear separation between them. OK, but if you have the module separation, we also wanted like a layer separation. So then if you want to replace a part of the app, so for example, instead of using share preferences to save some data to use room, we decided to also create layers. So we had data, domain, and UI layers. But actually, this is pretty much how our app looked like. I wanted to create a better diagram of this, but I think this shows best how tight the dependencies were in Plaid. So we knew we wanted to fix it, and we also knew that we wanted to use Kotlin. And we knew that the language features that Kotlin brings will also shape the way we're architecting our application. So one of the first decisions that we had to make is decide how are we handling asynchronous work. So initially, Plaid was just using retrofit2 calls to handle, well, background work. But actually, that meant that only the network requests were done on a background thread. So things like the business logic was done on the UI thread. So OK, definitely, this shouldn't be used only. So we looked at 3 other options: executors, RxJava, and coroutines. So executors, in the end, you're just creating a runnable, and that's about it. The API, let's say, is not the most usable one, and it's not supporting streams of data. It's just something that you're executing on a background thread, and then you're handling that result. Another option was RxJava, where you can work with streams of data. You really have a large number of operators. But the downside of this is that you have quite a steep learning curve. And out of 4 people in our team, 3 of them have never worked with RxJava. And it felt like actually climbing that learning curve, well, we consider it as a disadvantage, at least for now. And then coroutines have that ease of learning. It's easy to do the first steps with coroutines. And because a lot of times with RxJava, single, maybe, and completable are just used to move a work on a background thread, then with coroutines, these things can easily be translated into suspension functions. And on top of this, coroutines also support streams of data. So far, we haven't used streams of data. We haven't used channels. But this is something that we're considering in the future. OK, so looking at executors, RxJava, and coroutines, and all of their pluses and minuses, we did the math, and we decided to go with coroutines. And more precisely, we decided to launch the coroutine as close to the UI as possible. And this is because whenever we're launching a coroutine, for example, to do a request to the backend, chances are when we're exiting that activity, we want also to cancel that request. So we wanted to have the launch and the cancel of the coroutine in the same class. And the place where we decided to do this is in the view model. And also in the view model, the result from the coroutines will be passed to a live data. But I'm going to suspend for now the idea of view models, and I promise to come back to it a bit later. So these are the layers that we ended up creating. So we will have something like share preferences or a database, a local data source, a remote data source, a repository that would work with these 2, and then as part of the domain layer, use cases that will work with repositories, and in the UI, view models, activities, and XMLs. And let's go over actually every layer and see what exactly we've done there. Because before we started implementing, we decided to create a set of rules for each of these classes. So let's start with the data layer. So the API service is using the retrofit2 coroutines Kotlin coroutines adapter, where in your service, you're actually returning a deferred of a response. Then, for the remote data source, we decided that its role is just to construct the request data and actually fetch the data from the service. It will depend, of course, on the API service. And as an input, it will only get the request information. And as an output, a result of type response, this being the response that we get from the backend. So what's this result class? So we knew that we wanted to express in a way the fact that we got the data either with success or with error. And the way to do this is with seal classes, because with seal classes, you can only have a limited type. You can decide what's the type hierarchy. So often, you end up using the seal classes, or we end up using the result with when. So we were checking, OK, what should happen in case a result is successful, and what should happen in case of error. But because we wanted to make sure that we're always handling this, so in case we're not handling the error case, we wanted the compiler to tell us something, the compiler to tell us that we had an error. So something like the when expression must be exhaustive. Well, in Kotlin, when is only exhaustive when it's treated as an expression. So this is what we did. We treated when as an exhaustive. So we actually just created an extension property to t, and then we just return it. Like this, the compiler will really force us to handle all possible branches on the when. OK, getting back to our remote data source, let's see how an implementation looked like. So we would have a comment remote data source that would depend on a designer new service. So inside, in order to post a comment, we would have a suspension function that would get as a parameter a body for the comment and would return a result of the comment response. In the implementation, we would build the request, and then we will trigger a request to the backend, and then await for the response. And then we will handle the success or failure case of the response. But actually, this code is not complete. Because, for example, if your device is offline, this code will crash. So what we need to do extra is to wrap this inside a try-catch. So this means that for absolutely every network request that we make, we had to add this try-catch. We didn't want to do that. So we created a top-level function, which is, we called it a safe API call. And this is also a suspending function. And most of all, it also gets a suspending lambda as a parameter. So inside this function, we'll just call the lambda. And then in case an error is thrown, we just return a result of error based on the message that we passed as a parameter. So this means that in our remote data source, our code now looks something like this. We'll just call safe API call. We would put our post comment method as a call. And then we will define an error message. So this means that when we're implementing the post comment, we can focus on what matters, on creating that request and handling the response from the backend. OK, next, we work with a local data source. So the role of the local data source is just to store data on disk. It depends on either shared preferences or database. For now, we're still working with the shared preferences, but we think that because the local data source is the only place that knows how to save the data, it shouldn't be hard to replace the shared preferences with room, for example. So as an input, the local data source gets the data to be saved, and then at the output, the data that was saved. The class that works with the local data source and the remote data source is the repository. Its role is to fetch and store data. And optionally, we can decide to do also an in-memory cache. Its input would be the IDs of the data that needs to be retrieved or the data that needs to be saved. And as an output would also be a result of type response. OK, so I was saying that we want to work with suspension functions here in the data, but also in the domain layer. So this means that the repository, so the suspension functions from the repository would be called from the domain layer. But the truth is, our code wasn't like this. We were still refactoring Plaid from Java to Kotlin. So our code was something like this. Part of the repository was called from Kotlin UI, part from the domain layer also written in Kotlin. But we also had, of course, calls from some layer in Java. So if we have something like this, like in our shots repository, we expose a search suspend function. Well, if you want to handle this in Java, or to call this in Java, this is what you'll need to implement. You'll need to define a continuation, and there define what's the context, define what should happen with resume, what should happen with resume with exception, and then you also need to make sure that you're canceling this. So it felt like, OK, this doesn't look so nice from Java. So we looked again at what we have in the repository. And initially, we saw that there we were also handling the canceling of the calls. So at that time, we were working with the calls from retrofit, and we made sure that in certain cases, we were canceling all the searches. So also, right now, the repositories are singletons living in the scope of the entire application. So it was OK for us to handle the canceling like this. Also, initially, we were calling the search method also with a callback, so with a resolve callback. So it felt like, OK, for now, while we still have the Java parts, let's just use jobs, so coroutines jobs instead of calls. So like this, we make sure that indeed we're canceling all of our coroutines when needed. So we did this mix of callbacks and coroutines, which isn't that nice, but it felt like it was a good enough compromise. A good enough compromise until, step by step, we refactored the application. And then we saw that, indeed, with time, as we refactored the specific flows, going from this to how we actually wanted our code to look, so to suspend functions, wasn't really that hard. It wasn't hard to get rid of that callback. OK. Another problem that we had was this. So if you look at these two methods, you'll see that they're very similar. They both get a string and two longs as a parameter. So the difference being that when you're posting a comment to a story, you actually need a story ID. When you're posting a reply to a comment, you need a parent comment ID. So what we would have wanted to have is to enforce that type safety. So we would have wanted to have just post comment, but with two clear overloads, with one with story ID and one with a comment ID. This is possible. To do this, you would implement your own data class that wraps that ID. And then in the story and in the comment, instead of having longs of type IDs, you would just have your story ID object or comment ID. But the downside of this approach is that extra object creation that you have to do. And this is why we look forward to Kotlin 1.3 to be out, because here the inline classes were released. So with inline classes, all of this extra object creation is no longer needed. With inline classes, automatically the compiler will box the things for you. So the story ID will behave as a long, what we need. So overall, for the data layer, we had the repository, the local data source, and the remote data source. And for each of them, we defined clear roles, dependencies, inputs, and outputs. For the domain layer, we used use cases. So use cases are the ones that process data based on business logic. And they would work with either the repository or different other use cases. As an input, they usually get IDs, and as an output, a result of type object. So what's more important is that the use cases should be very lightweight. They only do a single task. So we wanted to somehow enforce this. So let me give you an example. So when we want to post a story comment, we would work with a comments repository and a login repository. So our method would look something like this. We would have a body and a story ID. So this means that whoever calls this kind of use case doesn't know that we also need the ID of the user. And it's only the role of the use case to know that it needs to get this kind of information from the login repository. But because the use case should only have this one task of posting a story comment, it means that this should be the only public method that we expose. So what we ended up doing is working with the invoke operator. So by implementing the invoke operator, it means that we can call a class as we would as a function. So in our case, we can just call post story comment use case of the comment and of the story ID. And even more, as a naming convention in our team, we decided to drop the use case completely. So like this, our call just looks like post story comment, and that's it. The class that calls this doesn't care about how this is implemented. But we know that under the hood is a use case. And all of the logic that comes with it, it's all separate. So because you can only have one invoke implementation, we decided this should be actually the only public method inside our application, and all of the other methods to be private. OK, let me tell you about another problem we had. So in our designer news story, we had, I was saying, threaded comments. So this means that here we have something like 4 layers of comments, so a reply to a reply to a reply to a comment to a story. But what we were getting from our API was something like this. For a story, we would get the IDs of the first layer of comments. So then we would need to request the IDs of those comments, where we would get the actual comment, but also the IDs of the replies. And then we would get those IDs, and then get the replies to the replies, and then again the replies to the replies to the replies, and so on. So what we were ending up with was with a list of lists that afterwards needed to be matched. Whew, that's a lot of operations we had to do there with collections. So we worked a lot with extension functions from the collection API. So for example, here to match the comments with replies, we use functions like group by that just does all the heavy lifting for us of mapping a parent ID, so an ID of a comment, with that list of replies. Similarly, we use something like map in order to create that transformation. But next, all of our comments also had a reference to the user ID, so to the user that posted it. But we didn't want to display the user ID. We wanted to display the name of the user. So we had to create a set of all of those users that added a comment to that story, and then do another request to the backend where we were actually getting the entire user information. So here, again, then afterwards, we had to map it and then create the new list with the new comment with replies and user information. So here again, we ended up using heavily the collections. So we also used methods like associate by. But apart from the collections, we also used sequences. So sequences are lazily evaluated collections. So the main difference between these is that with sequences, when you have multiple steps that you need to perform on the list, like in our case, flat map and map, with sequences, all of these operations are applied on every item. With collections, all of these operations are applied on the entire collection. So this means that for every step, a new collection is being generated. So this means that if you wanted to reduce the number of objects that you're creating, sequences are better. So it took me a while to just explain our business logic, but you saw that the code was so simple and easy to read. So methods like this, like for each, map, flat map, group by, were extremely useful for us. They reduced the boilerplate a lot. So in general, whenever you have to work with collections, check out first the extension functions from the standard library. I'm pretty sure they'll be very useful for you too. OK, so we looked at the repositories and use cases. The next is the UI. So for the UI, we defined a view model. And the role of the view model is to expose data to be displayed to the UI. And it would also trigger actions on use cases based on the user's actions. Also, the view model is the place where we're launching and we're canceling the coroutines. It depends on use cases. And as an input, it can optionally have an ID if, for example, this is a details screen, or it can have user's actions. And as an output, it would have a live data of a UI model. So for example, when we need to build the view model for the story activity, we would have a story ID and also several use cases. And we would extend from the view model. Because the view model, by default, doesn't have any arguments, we had to implement our own view model factory. And we decided to implement a view model factory for every view model that we had. Even more, we wanted to keep that immutability of the view model. We wanted to always keep that story ID immutable. So this means that we had a view model for every activity. So if we had multiple instances of the same activity being open, each of that instance would have its own instance of a view model. In the view model, we would expose the UI model via live data. But in order to actually set the values on a live data, you would need to work with a mutable live data, because this is the class that has the set and post value functions. But because we didn't want the activity that uses this view model to also be able to modify this, we decided to use a backing property of type mutable live data and only expose a live data. And we decided for events like opening a URL or showing a toast to expose separate live data. And more precisely, these would be a live data of an event. This is because these kind of events, like opening a URL or showing a toast, is something that should be done once, and then that's it. Whenever the activity is recreated and then we start observing that live data, we want to make sure that we don't trigger that request again. Because in the end, live data is just a data holder. So we use this event class where we're just wrapping the actual content, and we added another consumed property. And then once the object is read from the live data once, we're changing this value. So consumed would become true. I'm not going to go over the options that we've thought about before using event, and I definitely recommend checking out Jose Alcereca's article on live data. He goes there over several other options that we thought of, and their disadvantages and advantages. OK, so the view model was actually used from two different places. It was used from the activity and from the XML. So in our activity, we would use a late init view model. And this is because we know that the view model will not be null, and it's going to be initiated later on in the onCreate. So in the onCreate, we will work with the view model providers to actually get the view model. In the XML, we are using actually data binding. So this means that we define a view model variable as part of our data block in the layout. And then in the text view, what we're doing is working directly with the data from live data. Because data binding and live data have this nice interoperability. So this means that we can just do this in our XML. So we looked over the view model activity and XML. I think because Plaid is such a UI-heavy application, it's still the part where I think we can do better. We are still considering of maybe using a presenter, maybe splitting that action, that responsibilities even more. But these are overall our main layers, the data, domain, and UI. And creating these kind of separation, these kind of rules really helped our team to build things easier. We knew what are the guidelines. We knew what the restrictions were. OK, so overall, we knew that we wanted to fix the broken functionality, and this is something that we mostly done. So we can say that the product part was mostly handled. But then we saw that apart from defining these layers and modules, working with Kotlin properties like seal classes and delegates and so on really helped us build this kind of modular and extensible architecture that we really wanted, or help us do this now and in the future. So please check out the Plaid app.io, so become beta testers so we can see what kind of errors we've created while refactoring this. And because we're still in progress, keep an eye on what we have on GitHub. So thank you on behalf of the Plaid team.